What I'm going to do today is to talk about the new research I've done in the area of harmonics. We've talked about the fact that the we have experienced that the Russian pyramid will amplify energy fields, and we haven't had a kind of a basis, a geometric and harmonic basis upon which to validate that. So that's really what we're going to be talking about today. I'm going to be talking about the science of mediation, which discusses this is ancient knowledge going back to the time of Plato, but we use arithmetic, harmonic, and geometric means. And what we're going to be able to do today, and this is the key takeaway, we are now going to show why harmonically the pyramid geometry is such a great amplifier of pyramid energy, and why it seems, harmonically to be the optimal geometry for that purpose. So that's what we're going to do. And I'm going to go ahead and share my screen now. And
I haven't even seen this information yet or heard it. So I have my notebook ready.
That's right. That's right. I'm not keeping it from Lisa, but we did an interview a couple of days ago, and I was telling Lisa then that I needed just a little bit more time. So anyway, I'm pretty much ready to go. Finished the slides about 30 minutes ago. So here we go. Nothing like being 5 minutes ahead of your audience. So anyway, I'm calling this Decoding the Matrix, Discovering the Mathematics, Geometry, and Harmonics Driving Creation. That is actually the working title of what's going to be probably the second book. Our first book, Lisa and I are writing, we'll talk about that later, is going to be specifically about the Russian pyramids, their history, where we find this geometry, all of that, and the ability to amplify this with the fields and so forth. But this second book, we're going to, I'm really going to be taking some of this original research that I've done over the last year, and including that which I'm talking about today. And I'm kind of making a bold assumption here, but I believe that I can start to put together a dynamic model of the creative process based upon some of this research. So that's just sort of a backdrop. Before we start, I just want to give you this introduction to today. This comes from Scott Olson, who wrote the book, The Golden Section, Nature's Greatest Secret. And the quote says, "Nature holds a great mystery, zealously guarded by her custodians from those who would profane or abuse the wisdom. Periodically, portions of this tradition are quietly revealed to those of humanity who have attuned their eyes to see and their ears to hear. The primary requirements are openness, sensitivity, enthusiasm, and an earnestness to understand the deeper meaning of nature's marvels exhibited to us daily. Many of us tend to walk through life half asleep, at times numbed, if not actually deadened to the exquisite order that surrounds us, but a trail of clues has been preserved." And to be quite honest, that's kind of what's been driving me. When I read this several weeks ago, as I was reading this book, it really kind of summed up my research experience. I've been asking the universe to give me clues as to where I need to go. All of this is rediscovered information, so it's not like, I have any special capabilities here, except that I've been listening to my intuition, which, as you'll find by the end of the session, is highly improved by the use of the pyramid harmonically. So I'm going to review just quickly. So if there are people who are watching the video who have not seen some of the previous work, there's three major things that I have done in the research realm over the last year that point to the significance of this geometry in the creative process. And the first of these, if you look on this page, there's a diagram on the left side. This is a diagram in a book called Sacred Geometry, Philosophy and Practice that was written about 40 years ago by Robert Lawler. And what Lawler was doing there, he's depicting the Platonic solids. It's hard to, they're not even all in that diagram, but they are being both circumscribed or inscribed by 9 circles. And there's no information from Lawler at all as to what this represents. But I decided, because I knew that this wasn't a nested model, to try it in 3 dimensions. And on the right side, you'll see what I did was to plot those in 3 dimensions and plotted those circles within the geometry of the Russian pyramid. Now, getting 9 circles to fit in the pyramid proves nothing in and of itself. But what is important is what I'll show you on the next 2 pages. These circles, in the first case, we have 2 of these circles who intersect, one at the base, if you'll look at the green, and one at the apex. And in the second case, a midpoint in the apex. And that was surprising to me. I mean, I didn't know what to expect, but I was so happy to see it. But that wasn't enough for me to be convinced. So I went ahead and looked at the relative ratio relationships between the center, apex, and base of these 9 circles inside the pyramid. And I found all of these proportions as well: the square root of 2, the number 2, square root of 3, and the square root of 5 in these ratio relationships. That cannot be an accident. So I knew that this ancient diagram, which was known to Leonardo da Vinci and others in that era, but I think went back thousands of years, this could not be an accident. So, what I came away from this with last year was that that diagram is pointing to the creative process occurring within the boundary conditions of the Russian pyramid. So that's just a quick review of number 1. About 3 months ago, I did a video on this next topic, which is universal scaling. For those of you who know the research of Nassim Haramein, Dan Winter, Marshall Lefferts, all of these people have been finding phi as a universal scaling constant in the universe. But no one had proposed a universal scaling formula for that. And for some reason, they overlooked the very Fibonacci formulas that create what we know of as the Fibonacci series. Unfortunately, they all seem to have attributed, this phenomenon of phi convergence, which is graphed on the bottom right of this page, as if it only occurred with the Fibonacci series as we know it, which has a starting numbers of 0 and 1, when in fact you can take any set of numbers, starting numbers, and achieve this very same phi convergence. And that's relevant. Here's the formula for that. We don't need to go through that. You can come back and look at it later in the replay if you'd like. But this is just really restating these formulas as a generalized set of recursive formulas. And it works for any 2 numbers other than initial numbers of 0 and 0. So we have a universal scaling formula, and this is the key, because although we start with slightly different varying numbers at the beginning, there is a very rapid convergence to the phi scaling ratio, which is inherent in the Russian pyramid. So, what this is doing, I've got 5 examples here of starting numbers. We start with different ratios, but they all, if you notice, that angle always converges very rapidly to the angle of the Russian pyramid. And something I just put in last night, you can see this picture of Big Ben up at the top left, and then here on the right side, I did a blow up so you could see this a little bit easier. If you notice, the Big Ben spire is not straight. It's got angle to it. And so one thing I may do before I publish the book is try to determine whether, there is some relationships that we can define between there, and you see this kind of spire all over the world as well, but whether it relates to any specific geometric form. If you look at the bottom left two examples, you'll see that that curving out is occurring there. So I think that the ancients knew about this scaling phenomenon and were demonstrating it in Big Ben, and I'm going to do research on those as well. But anyway, ultimately, if you go back and look at these, you notice, for example, I have 5 scenarios here. Initial ratios of these two spheres, 3 to 1, 2 to 1, 5 to 1, 3 to 2, and so forth. You notice that each one of them gets a little taller. That the 3 to 1 is kind of a squatty looking, version, and they all get longer and narrower as we go on. Well, that's not necessarily a surprise because we see pictures of toruses of different shapes and sizes as well. As it turns out, a perfectly spherical torus occurs when you use the three-dimensional phi scaling geometry of the Russian pyramid. But what I'm showing you, this is just hints of where the next book is going, because I believe we're going to be able to tie a model together with all this information I'm going to show you today and the torus to come up with a model of creation. So to get to what we're talking about today, which is Russian pyramids, harmonics, and the science of mediation. Again, this is quick review. I've had this slide in before, but the diagram on the left depicts the refraction of light. This was a study done about 5 years ago, and essentially a person took a pipe and put a glass sphere at the end, put light through it, and measured the angle of refraction. Guess what? Exactly the geometry of the Russian pyramids. On the right, we have the megaphone, and again, within the limits of measurement here, that we're seeing that there is a relationship, a scaling relationship in the geometry of the megaphone as well. So these diagrams are pointing to the ability of the Russian pyramid to precisely scale and amplify frequencies. So what I wanted to do, and that's what drew me to this, was to discover how and why this occurs. And that led me to what's called the science of mediation, an area of esoteric study that dates back at least to the time of Pythagoras. And that's what we're going to be talking about. That's the methodology we're going to be exploring today. So as you can see, I'm going to keep the math simple here. I'm just showing you this. You can see this is a diagram of how the means that we're going to be talking about, which is the arithmetic, the geometric, and the harmonic means, can all be derived from the circle. So we're not going to go into that, but just so you get an appreciation of where that is. So give you a few basics about the science of mediation. The cornerstone of ancient philosophical mathematics is called the science of mediation, which is the observation of mean terms. And mean is like an average. We'll get into that. But in these esoteric teachings, there's a major distinction that's made between a ratio and a proportion. And so I just want to make this point quickly. A ratio is a comparison of two objects, their size, quantity, or whatever, and that ratio would be described as A is to B. Now, when we do fractions, we don't put the colon, we put A and then a slash, or put it on top of B with a division sign in the middle, but that's essentially a ratio. Now, a proportion is a relationship between two or more ratios. And the way you'd say that in plain English, one element is to the second element as a third element is to the fourth. And, in starting into mathematics, you'd say A is to B, is C is to D, or in pure mathematics, A is to B as C is to D. Now, the Pythagoreans call this discontinuous proportion. And Plato, as you can see in the next bullet, he didn't feel that that was a way to achieve what's called essential knowledge. He said that the only way to really get to essential knowledge, which is knowledge of the universe and its structure and our place within it, was to use what's called a three-term proportion. And that is simply A is to B as B is to C, or in mathematical, A colon B double colon B colon C. So now in this tradition and the way Plato looked at this three-term proportion, it is the perceiver, which is us, or our consciousness, which can be defined as B in this equation, but it's us who form the equivalency or the identity between the observed differences. This is kind of like saying between this world of the seen and the unseen. We are the intermediary between that. So Plato looked at mathematics philosophically and said that this was the way to determine, essential knowledge. And I think I've discovered one of those essential pieces of knowledge, through this exercise. So I'm not going to bore you with all of this. There's mathematics here, but you have arithmetic means, you have geometric means, and harmonic means. I will read from Robert Lawler's description. This comes from his book, what those differences are, so you can begin to get a feeling for what these different means actually mean. The arithmetic proportion, or arithmetic mean, contains the law of addition and its inverse subtraction, and describes the relationship which gives the natural series of cardinal numbers, for example, 1, 2, 3, 4, 5. The geometric proportion contains the laws of multiplication and its inverse, division, and describes the relationship which gives any series of geometric progressions. As we've said, addition and multiplication are mathematical symbols for patterns of growth. The harmonic mean, however, is derived from a combination of the first two. It is formed by a multiplication of any two extremes, A and C, followed by the division of this product by their average or arithmetic mean. So the harmonic mean takes into account both the arithmetic, which is the addition and subtraction, and the geometric, which is the multiplication and division. And it brings them together in the harmonic mean. So as he gives some examples, given two extremes, 6 and 12, the product of 6 and 12 is 72. The arithmetic mean between 6 and 12 is 9. And the harmonic proportion is 12. So you can come back and look at this. I don't want people's eyes glazing over with too much math here, but key distinctions between these, we talked about these before, but to reiterate, the arithmetic mean contains an equality of difference, which means addition and subtraction, but not of ratio or multiplication and division. So to give you an example, in the arithmetic proportion, if you take 2, 4, and 6, you can see that 6 minus 4 is equal to 4 minus 2. They're both equal to 2. So there is an arithmetic ability to add and subtract in that proportion, but the geometric 6 divided by 4 is equal to 1.5, and 4 divided by 2 is equal to 2. So there is no geometric ratio there, and then, or of multiplication and division. Similarly, geometric means, contain that equality of ratio, but not of difference. And again, using examples of 2, 4, and 8, 8 divided by 4 is equal to 4 divided by 2 is equal to 2, proving the equality of ratio, but 8 minus 4 is 4, and 4 minus 2 is equal to 2, so there's not an equivalency of difference. Finally, the last interesting thing to know about harmonic means is that one of the fascinating characteristics of the harmonic mean is the fact that it is always the inverse of the arithmetic mean. So for an example, with the numbers 2, 3, 4, and 5 is an ascending arithmetic progression, while the inverse of those, 1/2, 1/3, 1/4, and 1/5, is a descending harmonic proportion. I'm not expecting everybody to remember all this, but you can see how all of this weaves together. Whenever you're going to be doing universal scaling, you're going to need to have be able to take care of additive functions and multiplication functions. And in order to do that, we're going to see there are specific geometries, which is, of course, the Russian pyramid geometry that handles that best. So again, so a few more observations. All three means always fall between the values of the A and C for any particular observation, which are the apex and the base. The arithmetic mean is always the largest, followed by the geometric and harmonic mean. The arithmetic mean is always the midpoint between the apex and the base. And if you think about that, if you have a base of 0 and an apex of 1, the midpoint is going to be half, which you arrive at by adding 0 and 1 and dividing by 2. So it's nothing more than a proof of the arithmetic mean. Now here's some interesting information which I only was able to gather through doing some grunt work with Excel spreadsheets. But the ratio of the arithmetic to geometric mean is always equal to the ratio of the geometric mean to the harmonic mean, and we'll see this in a few minutes. But and finally, the ratio of arithmetic to harmonic mean is always the square of these other two previous ratios. So there's obviously some very interesting and potential for scaling, given the fact that these ratio relationships can be found consistently, no matter what we start with in terms of numbers or what I'm going to call a scaling interval here in a minute. Now, in some scenarios, and this is where it starts to come together. In some of these scenarios, meaning we'll talk about what a scaling interval is and what the scaling rate is in a minute, but in some scenarios, the geometric means coincide with the values of the base and apex that we're going to be formulating here. So what we'll be showing is that coherence, and I'm calling that concept coherence, occurs only when the scaling interval, we'll define that in a minute, is equal to or is a multiple or division of the scaling rate. I know you won't remember all this, but we'll get to it here in a minute. However, the arithmetic and harmonic means are still not coherent with the base and apex points that you derive through these recursive formulas to achieve these ratios. Now to the takeaway, and this is the important thing to focus on, because this is what I proved. There is only one combination of scaling interval and scaling rate which brings all of these points, the apex, the base, the arithmetic, geometric, and harmonic means into coherence. This occurs with a scaling interval of phi cubed and a scaling rate of phi or some derivative of phi. It could be phi squared, it can be square root of phi cubed, doesn't matter. But the key is that this set of conditions is only found within the geometry of the Russian pyramid. So now you know what we've concluded and the observations we're going to see, but I now want to try to make some sense out of all of that for everyone. So what I did a whole bunch of different calculations to make sure that I wasn't missing anything, and I'll show you here in a minute what I did do. But this is a just a summary page. And when I say arithmetic mean coherence, geometric or harmonic mean coherence, what I'm talking about is when I plot these, do any of these means fall onto the apex and base points of the circles? And you're going to see in certain cases the answer is yes. And the way that you know whether that's going to happen, I'm going to define the scaling environments here on the left so you can understand. C divided by A, that's the apex divided by the base of each of these circles we're going to be plotting. If in the first example, the ratio of the base to the apex is, if it's a doubling and you're so that's the difference between the height and base, and you scale at that rate, then you're going to have geometric coherence of the geometric mean, which means that the geometric mean will fall on either the apex or the base points of at least some of the circles. And you can see that happens. Go down to the next example with a yes. We have 5 as our initial scale with quintuples coupling. Well, it has geometric coherence. We do phi with phi scaling. We have geometric coherence, and so forth. But the only way to bring arithmetic and harmonic mean coherence to this diagram we're going to be plotting is by using an initial scaling interval of phi cubed, which is the geometry of the Russian pyramid. So this is a summary table that proves what we're going to be pointing out here. But I tested all different kinds of scenarios, and as I say, you can get this geometric coherence in certain cases, but you can't get all three, the arithmetic, geometric, and harmonic, to line up properly with the base and apex plotting points, unless you have that phi cubed geometry. So here's an example. I'm not going to bore you to death, but I hope. But I did a whole bunch. This is kind of an analysis of what I summarized on the previous page, and I'll show you how it works. The first example we have here, we have C divided by A is equal to 2. Now, what does that mean? We've got a top of 2 and a base of 1. So we have double scaling. And then we scaled both of those units in doubles. So we went 2, 4, 8 for the top and 1, 2, 4 for the bottom. And what we see, you're not going to see it on this page, but we will prove it to you subsequently, is that the geometric mean of these, although you don't see it right now but they're going to fall on the apex and base lines when we expand the scaling into something more than just, or into finer divisions than just octaves. But that's going to happen. But the key set for you all to look at, if you look about 2/3 of the way down, you're going to see, my cursor is there now, C divided by A is phi cubed, so that's the initial interval of scaling with phi scaling. Now, why is this important? I want to show you that, and you'll see this more in a few minutes, but the rate of change is phi. The relationships between the arithmetic and the geometric means are 1.27202. That's the square root of phi. And the change between the arithmetic and harmonic mean is phi. So this is the only set of conditions where you're going to find phi scaling not only in the means, but also in terms of the relationships between these various means and relating to each other. So a lot to take in, but now I'm going to start to show you some of this and actually how it works when we break down the harmonics a little bit better. This is an example. I told you we were going to do this earlier of just take this example where we start with doubling one and 0.5, and we do double scaling. Now, if you notice, every fourth one of these I've highlighted because we'll call these a unit, but we're actually subdividing each of these units into 4 pieces themselves. And you'll see the reason for that in a minute. The geometric mean, let's start down at the third one that's in bold print, which is 2.82843. Now, if you look over, you see, if everyone sees that one, that's the third bold one. Now we're going to go over to column C. And if we go down about, well, just 2 lines up from that, you'll see that 2.8243 is there. And then you can see that they follow. They become, coherent with the apex and base points. So the geometric mean in this situation, which we summarized earlier, all of the geometric means, when we divide this into essentially half or quarter scaling units, you're going to find that each one of those geometric means falls onto the base. But now here's the one that, of course, is reflective of the pyramid and its geometry, and you're going to find these relationships everywhere. So let's start with our arithmetic mean. Again, we're going to start with the second situation, which is 1, that's in italics. And if you notice, the 1 in the arithmetic mean column, you can find that in 2 different places. You're going to find it as the very first item in column C, which is 1. And you're also going to find it 2 full units down in the A column. Then you'll see the 1 there. And if you can then follow through, and you can see that every one of those numbers, once you see where they start, they all fall into line with both the apex and the base readings. Now, the geometric mean also is in, it falls onto both the apex and base lines. Let's go down to the third unit, which is 1.27202. And then let's go over to the column C again. We start at the third location from the top, just 2 below the 1.00, and you'll find 1.272. And you can follow through, and you see that those numbers follow perfectly, inside. So they're hitting, every one of these geometric means is hitting on the values for column C. They're also going to hit on for column A. If you go to the very first geometric mean of 0.48587, go to column A now, and if you look down 6 items down, you'll see 0.48587, and it follows in that column as well. So everything matches up. So the only one that we have to still talk about is the harmonic mean, and we'll be able to find that by going first to the third bold, which is the number 1. And you'll see once again that the harmonic mean, if we go over to column C, the very first number is 1, and those numbers follow in perfect order from that position. And then if we look at column A, 0.38197, which is the very first entry in the harmonic mean column, that is the fifth number, or the second one that is highlighted in the A column. So every single one of these numbers, whether it's an apex, a base number, an arithmetic mean, a geometric mean, or a harmonic mean, they all fall together at the same points. And so I don't know if this is a term in mathematics, but I'm calling this geometric coherence of the base, apex, and means. And this is just a summary. If you want to go back in the when you're replaying this and check all this out, but I put it in Word form so you can follow through, go back to that schedule, but it shows you the relationships of each mean to the base, to the apex, and to other means within the system. And so the takeaway that you should, at the bottom of the page, only, and this is only the Russian pyramid geometry provides this geometric coherence among all points of intersection. Now to graph that for you, because it's really cool to see this visually. I'm going to show you. I graphed a full two sets of this 13. It's like intervals, and we'll see the finished product in a moment. But I want to show you how this is done piece by piece, how you begin to graph this. So this is the very first set of numbers. I'll go back to that. We have 1 and 0.236, 0.618, 0.4857, and 0.38197. So what I did in the very first iteration, I plotted those. If you assume the apex and B, the base numbers, plot those as a circle. Then C, the arithmetic mean, is in the middle. D, which is the arithmetic mean, is there. And then E, which is the harmonic mean, show up in those positions. Then we start this process of this is a recursive formula process, but now we take the second iteration and we plot all of those numbers. I have them all listed here if you want to come back and look later and check this out. But you're going to see that's the second version of this. Then I did the third iteration. I'm not going to go through this all, but I'm going to go now to the finished product. So on the left, this is 13 intervals of this plotted. And what I find fascinating, this is to me like an MC Escher drawing, if you know who he is, but you could never quite figure out what was up and down and so forth. But it depends on your perspective. This drawing on the left, you could perceive it as looking through like a pipe that's in front of you, or you could look at it as if it's a cone that you're looking at from the top. But no matter, what I want to show you is that each and every one of those points in all 13 iterations, whether they be base, apex, harmonic mean, geometric mean, arithmetic mean, are all, I plotted all of those, and of course, they all fit together. So just to show you that there's no cheating at the top where you can't see very well, I did a blow up of that in the on the right side of the page. So there is complete what I'm calling geometric coherence in this process. So, but to show you what happens when you don't use that precise initial interview and scaling of phi, what happens when you try to do a similar plot. And we looked at that example of doubling, having an initial ratio of 2 with a doubling scale. And this is what you come up with. You see all of these dots are either harmonic means, geometric means, arithmetic means that are not falling in line with the apex and base of these characters. And I've blown that up to show it more fully on the right. And once again, same idea. Even if you have phi, if you start with a ratio of phi and use phi scaling, you're not going to get the same result. And so this, kind of relate this in some respects to the Giza pyramid. It doesn't have this, it has phi in its geometry, but it doesn't have the phi cubed initial, initial situation. And so what happens when you plot that, you see that there's not a coherence in the Giza pyramid between the coherence of all of these points coming together. So geometric coherence, and now to transition. What we're going to do now, we plotted this. This is very simplistic, folks, and what I'm looking for is an animator to help me to do this in 3 dimensions and to make it real time. But hopefully this has been enough for you to be able to visualize this. But now we're going to, from this point forward, we're going from the world of geometry to the world of harmonics, and this will show you how harmonics and geometry interplay with each other. So I want to just give you a quick definition of harmonic coherence. And harmonic coherence is the property of wave-like states that enables the waves to exhibit interference patterns. At least 2 wave-like entities are combined, and depending on the relative phase between them, they add constructively or subtract destructively to form a consistent pattern. Now we can finally, hopefully what we just went through and you had to bear with me on for the last 20 minutes will start to make sense. Because now I want to give you just an introduction to harmonics and what's called constructive versus destructive interference. I'm sure all of you are familiar with the idea of a waveform. If you pluck a string on a guitar, it's going to vibrate. If you pluck a key on a piano, the string associated with it is going to vibrate, and it's going to go up and down around what's called a midpoint. So if you look at the top half of the diagram here, this midpoint is the green line that you see, horizontal line. This first example at the top of the page is an example of destructive interference. We have 2 waves which do meet, but they are what's called out of phase. They're 180 degrees out of phase. And so what happens, the way wave mathematics works, you always add up the relative values of each of those waves to come up with the composite wave. And so when you have 2 identical waves that are 180 degrees out of phase, what you actually end up with is a flat line. In other words, no resonance whatsoever. So you clearly don't want, when you start to work with harmonics, you don't want waves that occur in that fashion. And we know from our own experience that that's not the case with the Russian pyramid, because we have all experienced how it enhances and energizes its environment. So we know that that's not happening with the Russian pyramid. What is happening with the Russian pyramid is described in the bottom result. We've got a number of different waveforms that are constructively interfering with each other. So they may meet at the same node points, but instead of subtracting out from each other, in this second example, we take the blue and the yellow and we add those together. And so what we get is a waveform that's not flat, but is actually the sum of those 2 waves that are coherent. And it produces a much more powerful waveform. So those are the basic concepts. And the takeaway here is that the Russian pyramid geometry with its, unique scaling interval is the only pyramid geometry that maintains this perfect waveform coherence. And that thereby explains its amazing energy generating capacity. So what happens, you remember we saw all these other dots on the other diagrams that didn't fit in and so forth. Well, those are waveform midpoints. And so I'm going to show you what happens when you don't have those waves converging at exactly the same point. You've got an example here of interference with wave sets of different wavelengths. And so you look at those two waves, the red and blue, purple on the left-hand column here. They have different wavelengths, but when you add them up, you end up with this totally, asymmetrical waveform on the right. So what I'm trying to impress upon you is that's why having the coherence of these geometric points is absolutely essential. And when we plot these points, we're actually identifying the midpoints or nodes of a waveform at the point of intersection with the midpoint. To the extent that they occur at different points along the line, we end up with wave interference, which destroys the coherence of the combined waveform. So I'm just trying to give you a little bit of graphic, demonstration here, but that's what geometric coherence is essential to achieve harmonic coherence. So this is where we're gonna, I'll tell you this, well, we'll go on and I'll explain that in a minute. Now, this phi cubed initial scaling, which is reflective of the Russian pyramid, has been found, but has not been correlated or identified. But I found it in two other areas of research, and I wanted to point those out to you so that you can get a greater appreciation of the significance of what we've just been talking about. Marshall Lefferts, who's a colleague of Nassim Haramein, wrote a book about two and a half years ago called Cosmometry, Exploring the Holofractal Nature of the Cosmos. And one of the things he did, he came up with what he called just an interesting observation. Now I can, there's a reason for it that we've just figured out. But after, what he did was he drew a phi double spiral pattern, which I show up in the top left here. And what he did, he had a phi spiral. Well, it was almost like a graphing tool. If you go down to the bottom left and you look at that circle, it must have looked something like that. It's just he had that built, and I guess maybe he had little pinpoints like where he could put like a pin or something to hold the spiral at each of these node points. You can see there's 3, 4, 5, and 6, 1, 2, 3 at the beginning there. So essentially what he did was he was just playing around, and he noticed that no matter what point on this little model that he had, whether he started at 1, 2, 3, 4, what would happen is if he put that at a particular place and he just spun that model around, that it created the circle like you see on the outer rim there, and that circle occurred at the point of phi cubed, which is, of course, we've just realized is the only initial set that will allow for all of these conditions to for coherence. So it's not at all a surprise to me that he found that, because that phi boundary condition that he discovered is identical to the phi cube scaling interval of the Russian pyramid. So this is just another manifestation of the mathematics that we've just gone through. And finally, I wanted to show you, relate this to fractals and the Mandelbrot set. Uh, the Mandelbrot set came about as a result of the work of Benoit Mandelbrot in the 1970s. He said that he came upon this idea due to the omnipresence of what he calls recursion in nature. And to go back, we talked about the universal scaling formula being the Fibonacci formulas, and that's a classic example. The world is scaled recursively. So I'm not at all surprised that he, noticed that. I don't know if that's the manifestation that he noticed, but at the center of that was uh, this shape that he developed called the Mandelbrot set. It's very, very famous in nature. And Richard Merrick, who wrote where this diagram comes from, he wrote a book called Interference, a Grand Scientific Musical Theory. And that's where this diagram comes from. He refers to this phenomenon as cubic damping, but it's the same idea. This phi cube scaling is exhibited in this diagram above. And I'm going to show you how it occurs. If you notice at the bottom of the scale here, you can see he's got phi, and then he's got phi cubed, then he has phi to the 6th power and phi to the 9th power. Well, it's hard to see, but let's start with the large circle first. That's the one that's scaled phi to the 9th. The one to the left is phi cubed less. And then the one to its left is scaled phi cubed less. And then there's a tiny little dot at the end that you can barely see that's phi cubed as well. So that's what he's demonstrated here, that the scaling of the Mandelbrot set is in the very phi cubed scaling relationship that we found was necessary to keep coherence. And as Mandelbrot called this, he said this diagram is nothing less than the spatial boundary between chaos and order. So this phi cubed is showing up everywhere. And as we've now seen, we now can demonstrate harmonically and geometrically why that geometry is so important, because it is the only set of conditions that maintains coherence between the plotting points of the apex, base, and all of the various means. So that's a lot to go through today. I appreciate everybody listening, but I just want to go through the next steps for us. I could keep doing research probably forever and never get the book written, but I think this is a great place to stop with original research with respect to the book. So this is the last piece of a really major original research I'm putting into the book. Right after the first of the year, Lisa and I are going to start working on finalizing the book draft. So we're going to, our goal is to get this thing out in 2022 and maybe by the end of the first half of the year. So, we're going to be looking for editors, publishers, animators, a whole bunch of folks to help us with this. So if you have any ideas as to people who can assist with these, particularly, I need all of these. I need people to animate some of this stuff for me. Editors and publishers are all important. We'd love to get this book, as well publicized and have it reach as many people as possible, because I think this is going to be groundbreaking. I don't believe I'm not trying to pat Lisa and I on the back for this, but I don't believe there's going to be a book out there dealing with pyramids that's going to deal with science, mathematics, and geometry to the heavy extent that we're going to be in this book. So we're also looking for research funding to advance, our research. I can already tell that we're looking for research funding and for healing, but with this new data, I now know that we're gonna. I would love to be able to find, do some research in harmonics modeling, and also the development of this dynamic model of creation, which I think we can put together. So the other implications that come from this we now can look at some of the information again that the Russians provided us with respect to free energy. We know that these pyramids are said to, produce huge amounts of energy. They spontaneously charge capacitors and the like. And now that we have an understanding of the wave dynamics, at least even if just a glimpse of it at this point, we can see why that occurs. So we've got lots of stuff going on, and we look forward to really an exciting 2022 to be able to finish the book, get it out into the public, and get this information disseminated far and wide. So that's it for me. Lisa, go ahead and talk, give some comments, or anyone else who wishes to.
No, it's great. I love that information that you shared. I'm going to have to go back and look at a lot of it, and that's why you're the brains of the bunch, Charlie, because you can think of it all. And then I have to go back and double check it a couple of different times to comprehend it fully. But it makes a lot of sense. That's awesome. Frequency. What is it? What is the saying that Nikola Tesla said? The secrets of the universe or something is frequency,
energy, and vibration. Yeah.
And that's pretty much it, And it's awesome how it connects to the Tartarian Empire. I'm seeing so much of that right now, and I'm seeing so much of people connecting to that and to the frequency healing. And the pyramids as well. There's a lot of this information coming out right now.
So we know, and just to follow up on that, we know that the Tartarian architecture has this geometry. We know they had free energy. We know that other researchers in India say that the Hindu temples were energy generating plants. Tesla used this geometry. It's everywhere. So you bet. This now takes us from the final transition from math to geometry to harmonics. And so, I can't wait to continue research, but right now my focus is going to be on getting the book done. So anyway.
It's going to be a big year for us. It really is. I intuitively know that, not only with the book, but I feel we're going to get a significant amount of funding to provide our research, and that's going to be huge for us.
So anyway, if there are any questions, and I know we covered so much ground here that you can't even possibly begin to understand it all, but don't feel stupid. If you have questions, ask them, because there's no such thing as a dumb question. So
there is a question in the chat. Charlie Carroll wonders if you can please share the name of the initial book by Scott Olson, if you have it off the top of your head.
Oh yeah, it's Sacred Geometry. Well, let me see. Sacred Geometry. Tell you what, I'll go back and get it. Hold on. We'll share screen again. I forgot what it was as well. Let's see. I'm sorry, the golden section, Nature's Greatest Secret. You can actually get this book for free. It's a free download on my favorite public website called 1lib.us. So you can get that at that website, and that's where I got it. So again, just the number 1lib.us. Yep, that's it. 1lib.us. Perfect. So, all right. I don't know if there's anything. If not, well, I'd say everybody get back to wrapping your packages and doing your last minute gift shopping. And we will see you all after the first of the year. Before we leave.
So happy holidays. Merry Christmas. Happy New Year.
Right.
Merry, happy.
Yes.
I want to say goodbye to Ally again. Thank you again for all your help, and I know we'll be seeing you, but not in your former role. So we look forward to that and wish you the best of success in your new ventures. So
Yes,
thank you.
of course. We're gonna miss you,
Ag-
Ally.
Agreed, Ally.
Oh, thank you guys. Many, many thanks. Best of luck to all of you.
All
Oh,
right.
my internet is saying it's unstable. Thank you so much for everything, and best of luck with the book. I'll be first in line to get a copy.
That's right.
Yeah. Thank you for the opportunity. It's been phenomenal.
Okay. Well,
Merry
Yeah,
Christmas.
it's gonna be a
Happy
big year
holiday.
for you too, Ally.
Oh, thank you.
Sure is. That's great.
Yeah. Thanks, everyone.
all right. Does anybody else have any comments? Otherwise, we'll say goodbye. All right.
That's it.
Okay. We'll
Toodaloo,
see you
everyone.
in 2022.
Yes,
Have a
lots
great
of love.
holiday, everyone.
See you next year. Bye.
Bye-bye.